A lot of you have seen some of these Air Force 19-inch racks over the years in different pictures, different videos. Cosmic induction generator experiments is kind of one of the goals of where this was all going. In emediapress.com over the last X amount of years, there's quite a few pictures here, so I'm going to go through a little slideshow of what happened in April, something like that, when Adrian and Eric were both here for long enough to get the audio bay done. So this project has been going on for a long time, originally conceived about, I don't know, 8 years ago or something like that. One day, Eric's at my house working on a presentation. I start talking to him and asking him, hey, if I want to split water with no energy, and all I want to use is that electrostatic potential or the dielectric component of electricity without running current through water, how would you do it? And so that was the original question that was asked of Eric, where the audio bay came from. So that whole, the unit to your left is all audio. The unit to your right is the radio frequency. For different experiments, they can be used independently of each other, or they can be combined together. So the audio one, you know, there's been a handful of people who have successfully split water, basically just using voltage potential. This is an oversimplified explanation, but for example, water is a dipolar molecule, so if you have a capacitor plates with water in there and you put just electrostatic potential, you're basically going to polarize the water molecule. When you polarize the water molecule, I guess if you have the electrostatic potential up high enough to play like electrostatic tug-of-war, so to speak, on it, you can pull it apart so that that covalent electron is ripped out because the electrostatic potential is stronger than that. And so it's not a violation of Faraday's law of electrolysis. It doesn't apply because it's not electrolysis. You're not running current through the water. Any of that current inside is generated internally and is completely independent of that voltage potential at the plates when you're splitting water in that process. So somebody named Taeheehan who did it. I did a crude experiment. Didn't work for me. Eric knows of a few credible people who acknowledge that kind of method is done large scale at a big company that most of you would know the name of in Germany, I believe, something along those lines, or somebody that he knows alluded to something like that. And so there's different ways to do it, but the output of this is a very high, I guess you say a high fidelity audio amplifier that starts off with audio. Eric and or Adrian will kind of walk through the components. That stepped up again, and then it stepped up into the tube amp. So you basically have very lethal voltage coming out of here. Basically is converting the electricity to a very high voltage audio waveform that you can do different stuff with, to either put into a water cell, which we still have to test. The output of that could be running the Trump generator on a sine wave. You just get it sped up, have the high voltage output of that, and turn off the motor, and it should run it like a motor instead of running it in generator mode like what Haka says was doing. So it's really intended to be a universal unit, and the radio frequency one is a whole other project. This has been going on for a while, and as more that over time, the more Eric thought about it, he tried to make it more universal so we can use it for all kinds of stuff. This telluric, you know, ground transmission projects and cosmic induction generator, the water stuff, the Trump thing. I mean, it's just a real incredible system. Once the radio frequency bay is done, then we'll be able to show some experiments at another level that's never been shown before. Okay, so here's Adrian and Eric at the covered up bench over here. And everything you see on these racks, like the audio rack, 100% is all built from scratch, other than the light gray units, which is a Hewlett-Packard scope and a Hewlett-Packard oscillator. So this is one of the units that Eric is wiring up. So typically he'll do the design of the mechanical parts. We'll cut the standoffs, make these different plates, mounting plates, the whole 9 yards. Once that mechanical stuff is kind of put together, Eric will put the electrical components on there, wire it all up, and we'll test it, and then just keep going to the next one, and next one. So here's the audio bay as it's kind of coming together. Adrian is maybe either doing some troubleshooting or some final wiring, and when it gets towards the end of the day, Eric likes to sit back and watch other people do the work.
It's called
management. Here's a back view of one of the bays. That's the audio bay with a scope at the top. Jeremiah got in on some of the action, pulled him away from his stuff to do a little bit of machining and fabrication. think Adrian just fell asleep there at the bench. Yes. There's some long days.
I'll do a walkthrough of what we've got with the hybrid,
Okay.
how it works and everything like that, and then we will move straight into the demonstration.
Okay.
Okay, so let's explain the whole system here so we know what we're actually doing. And we'll start from the coil. So this is the final output coil. This is the same. It is not exactly the same coil that I use for the golden ratio discharge, but it's built on the same characteristics, on the same properties. It's a coil. It's a very straightforward coil. There's nothing particularly special about its design. When I designed it for the golden ratio, I made sure that there were no golden ratio proportions in it, because I wanted to actually see where those properties would lie, and I'm going to go into that in my presentation on Saturday. So it was designed so that it can produce a good discharge. So it has a very high voltage inversion. You can see the coil is long and it's narrow. It's got lots of turns close together. Although it is designed to resonate with its fundamental series mode at much higher than you would normally run a Tesla coil of this sort. It's nominally, this coil is about 3 megacycles open, and we are driving it at about 2.2 megacycles or so today. Otherwise, it's driven by, this is the generator that I produced in my lab and I bought last year for the golden ratio discharge. It's designed as a flexible high power generator for these kinds of experiments. It can be run as a linear amplifier, it can be run as a push-pull generator, it can also be run as a power oscillator.
So basically, this is the high voltage rectifier. This produces the 2200 volts DC, not much to see from the front. And this is the audio interface. This has got it's kind of like the mixing board in a radio station. You select your microphone or record player or whatever, and then you got their attenuator pot and your patch panel. And then this is the first stage of amplification, and also it controls the grid voltage in the tubes. So we call this the grid control unit. In radio work, this would probably be called an exciter. So this thing not only is audio, but the thing is ultra low frequency transmission, like submarine transmission and that kind of stuff, is also audio. So this also is a 1,000 watt ultra low frequency transmitter for testing Alexander's antennas. We're not near that point yet, but this would do that. So then this basically is a 50 watt amp, 100 watts max, and then this steps it up to about 1,000 watts.
Have you turned on the high voltage there?
Everything's ready to go here.
The high voltage is not on here.
Well, I don't want to turn it on until we do this.
Fine, okay.
I don't like any extra high voltage.
So what we need to do is we first of all have to strike the flame on here, and then we feed that with a single tone, and we produce a single, and the single tone is not coming from a speaker. It's coming from the flame. So the flame is acting itself as a speaker.
You turn that one off too? Yeah.
And then just check. Okay, when you're ready, Eric.
It's hot.
We also need to let it stabilize a little bit because everything's cold.
So this is the burning bush.
Let's just let it warm up a little bit, because the flame has to become steady on a particular hot spot of the ball.
And you can get a little
Otherwise,
bigger
it
than
tends to whip around.
You can get a little bigger than that, can't you? There you go.
I was just letting it
Oh,
heat
you're
up
getting
first.
it, okay.
Otherwise, it'll blow out.
Yeah.
So that is the burning bush. That's 2400 volts. When we did it with 48, it's almost twice the size. Wait for it.
That's the maximum rated frequency of the modulator. Beyond that, I might overheat. And I'll go down.
And go down to the low end as well, Eric. Notice the spatial depth.
Flame stable?
Yep.
Okay. Okay, I hit it.
This is self-funded. There's a lot of stuff going on at EPD Labs down in Nevada. EPD Laboratories, Inc. is a 501c3 nonprofit corporation registered in Nevada, and the organization survives by donations, pays the bills, you know, property tax, insurance, the whole 9 yards, and it funds whatever projects are down there. We could use you know, all the donations that we can get, and all donations are tax deductible. EricPDollard.com. That's Eric P for Paul. Dollard.com, ericpdollard.com. You can go on there, and I think there might be a donate link in the menu bar, or you can go /donate. And there's a PayPal donate link. That's probably the easiest way people can donate, where 95% of any donations come from. And anything that you're able to give, or if you know people who are really into this or would be interested in to support it, you know, send in a PayPal donation. You know, $5, $500, $5,000. Once in a blue moon, we'll get a $5,000, $10,000 donation. There's a recurring button. If you can put in, you know, $100 a month, $25 a month, whatever, it goes to the project, to exactly what it's supposed to be doing to further the electrical sciences with, you know, everything Eric is doing down there, and, you know, with Griffin and Haka says and Adrian, and all of us are kind of commingled in these projects and stuff, and it does take a lot of money.